So we study the continuous study on equation of line in space. So you have the vector equation. So our section is equation of line in space. Line in space. So we are going to study the continuous study on equation of line in space. So you have the vector equation of the line. You have this vector equation of the line r naught of t, r of t equal to r of t equal to r naught. This is a vector r naught plus some t into v, r naught plus t into v, and this has some more meaning than that of a straight line. So you suppose that you are starting from a point whose suppose you are discussing a linear motion. Suppose a particle starts from x naught, y naught, z naught. Suppose, and it moves along the line with a speed of modulus of v. Suppose you have the speed of modulus of v, and what is the position of t of the particle which is moving on this line after a certain time. Okay, position after a time t. So we can describe the linear equation of motion using this equation. So suppose for which you can rearrange or rewrite this equation as r of t equal to r naught plus, you take t times v by modulus of v. So you take modulus of v times v by modulus of v. V by modulus of v, and this is the speed. Modulus of v is the speed, and r naught is the initial position, and this is a unit vector in the direction of motion. So this describes the equation of motion on a straight line starting from the point x naught, y naught, z naught, so which gives the position. So this equation is actually gives the position of a particle at a time t whose initial position is at p naught and speed is modulus of v. So you consider an example. In this case, consider so this already you have done. So this is not the case. First question. So you have the second question. So this is a problem in your text. This question says a helicopter is to fly directly from the helipad at the origin in the direction of the point 111 at speed 60 feet per second. What is the position of the helicopter after 10 seconds? So here, what are the given things? It starts from origin as the helipad. So the helicopter starts from the origin and moves in the direction of 111. So suppose that this is x-axis, y-axis and z-axis, and you have, suppose this is the vector 111, vector 111. So the helipad is at here, the direction of light is this one. And our question is, and it moves at a speed of 60 feet per second. So our question is to find the position of the helicopter after 10 seconds. So by the previous discussion, you have r of t. R of t, this is equal to r naught plus t times speed modulus of v into v by norm v. So it is the unit vector in the direction of motion. So you have these things. This is the initial position, and this is the speed, and this is the unit vector in the direction of motion. So you consider unit vector in the direction of motion. So you have here what is the direction of motion? Direction of motion is in the direction of the vector 1, 1, 1. So you have unit vector u is 1 by root 3i plus 1 by root 3j plus 1 by root 3k. We are getting this from the fact that the direction of motion, so v is I plus j plus k. So modulus of v is square root of 1 square plus 1 square plus 1 square. So this is root 3. So u is v by modulus of v. V by modulus of v. So from this we are getting this one. And you have the initial position r naught is 0 at the origin. R naught is 0. So from the equation, r of t will be equal to, so you have this equation, this one, r of t, r naught plus t into speed times unit vector. So r of t equal to 0. R naught is vector 0 plus t times modulus of v. Modulus of v is the speed. It is given that the speed is given to be 60 feet per second. So it is t times 60 times the vector 1 by root 3 I plus 1 by root 3 j plus 1 by root 3k. By root 3k. So this is the vector. So you are getting this as 20 root 3 into I plus j plus k into t. So this actually gives the description of motion. So r of t. So our question is to find r of t after 10 seconds. So position after 10 seconds. So r of t. So t equal to 10. This is equal to 20 root 3 into 10 times I plus j plus k. So this means this is you have this is 200 root 3 times I plus j plus k. 200 root 3 I plus j plus k. So this is the position vector at, position of the particle after 10, or helicopter after 10 seconds of flight. This means after 10 seconds the helicopter will be at helicopter will be at 200 root 3, 200 root 3, 200 root 3. So you can plot the parametric equation or vector equation, parametric form or vector form, etc. So to verify your answers, you can have Geogebra with you. You have Geogebra with you, so you can use Geogebra to plot lines. So let us see how it works. Suppose you want to plot an equation of the form R naught, sorry, R of t equal to R naught plus some t times v, what you have to do is, in GeoGebra window you first define the vector m as R naught, components of R naught, x naught, y naught, z naught, the components of v as some n, or you can say that it is n as the vector v, so v1, v2, v3. So you run the command x equal to m plus t star n, you will get the equation. So here our for example r of t is equal to, what you are getting is 0 plus 200 root 3, sorry, 20 root 3 into I plus j plus k into t. You have this. To plot this, you write the equation m as 0, 0, 0, n as 1, 1, 1 in GeoGebra, and so you have to write t is actually here 200 root 3t. So to plot this, it's enough to write this one, 20 root 3 20 root 3 into n star n star t. So this will plot this our line or a path of the helicopter in GeoGebra. You can see that first of all you have to set your GeoGebra to 3D graphics view. 3D graphics view. So you just type the first vector. So you need not type n here. So m is equal to 1, 1, 1. 1, m equal 1, 1, 1. So you are getting that vector. So here you can see. So this is the vector 1, 1, 1. You have this vector 1, 1, 1, and our path of the helicopter will be plotted like this. X is equal to 20 star square root of 3, sqrt of 3, square root of 3 star T, sorry, star T, star T star into M. So this is T star. So you write this as x is equal to, so you can plot one more times. So this is the plot of x. So how? So this is the equation of line or trajectory, equation of the trajectory of. So this is the first quadrant, and this is the line in the example. So you can plot like this in Geogebra. So you consider the next question. So also you can plot the previous examples. What is the meaning of? So you consider this line. For example, you consider the first problem. That's our first problem. And the parametric equation of the line through -3, 2 -3 and q1 -1 4. So you can so to draw a line through 2 points, so you have the method here. So you may delete these things. So you have the window here. This is the first call. This is first quadrant. So you have first you have to input 2 points. Okay, so points are usually denoted. So and you plot the line through these 2 points. So that's the first case. So you A equal to our first point -3 to -3, and so that is the first point, and B is 1 -1 4, 1 comma -1 4 B. Now you take this, find the equation of line through these 2 points. So this is the required line in that first example. So again, make its color some blue. Okay. So this is the equation of the line there in R3 in the first example. Okay. So we delete this. So we can delete this also. And this is how equation of lines through 2 points is plotted, and we can have the uh, GeoGebra plot for the parametric equation, that we will how we plot x is equal to 1 plus 2t, y is equal to, so you consider this problem, this problem. So you consider a line through 3 line through 3 minus to 1 minus to 1 parallel to the line. So suppose parallel to the vector, suppose you are given with a given point p naught and a given vector v is 2i plus 2i minus j. So you consider 2i minus j, 2i minus j plus 3k. So how we plot this in GeoGebra? That is the next thing that we are going to illustrate. So consider GeoGebra window, and you input the first point, x is, so you can directly plot either x is equal to the initial position is 3 minus 2 1, 3 minus 2 1, 3 comma minus 2 comma 1, 3 minus 2 1 plus, so you have to define it. First of all, you define m to be 3 minus 2 1, 3 comma minus 2 comma 1. So that is the position vector of the initial point, and you consider the vector 2 minus 1 3. So n is equal to 2 comma minus 1 comma 3. So how now you plot the line in the direction x is equal to m plus t star n. So this is the line. So you can see that. So this is the line in the direction of the first vector, 3 minus 2 1. Sorry, in the direction of n. So you may color it. So this is the position vector of a point on the line. Position vector of the point on the line. And n is the a vector in the direction of the line L. So this gives the equation. This gives the graph of the line. Okay. So this is the meaning of a line which is parallel to a vector. So a given point will be given, a point will be given, and you are actually writing the equation of the line. So why I am saying all these things is it is just for visualizations. You can verify your answers directly. Now you consider a second problem. So we are going to discuss one more problem. Problem is this. How? Question number 3. Line through the point. Find the line through the point 3 minus 2, 1. Parallel to the line x is equal to 1 plus 2t, y equal to 2 minus t, z is equal to 3t. So you have this. This is, you may plot that x is equal to 1, 2, 0. X is equal to, initial position is 1, 2, 0. And the direction of the vector is 2, minus 1, 3. Okay. So that is, you may plot it. So you can delete all these things. Delete. And you can delete this. X is equal to 1, 2, 0 plus 1, 2, 0 plus t times 2 minus 1, 3. 2, so sorry, we have to define these vectors first, otherwise it will not work. So it will not work in this way. So you specify m as 1, 2, 0, 1, 2, 0. So that's a vector, and you specify n as 2 minus 1, 3, 2, minus 1, 3, and you can plot x as m plus t star n. Okay, you have this. So this is the given situation. You have this is a given line. So this is a given line, and you have on that line, this line is plotted using these two vectors. You have these two vectors, and what you have to show is you have to find a point. So for example, you consider the point, you have to find the line parallel to this line, the given red line, and you have to find a line passing through some. If you take this as a, the point is a as 3 minus 2, 1, 3, minus 2, 1. So you have to find the equation of a line parallel to this line and passing through this point. That's our aim. So you have to find a line passing through this point A, passing through the point A. So how this? Passing through the point A and parallel to this line. So this vector, that is actually the vector parallel to this line, will be parallel to the line through A. So that is the idea behind our derivation or solving the problem. Okay. So we consider the first line. So we can do this problem. It's like this. What are the given things? The line, these are the given things. Given the line that we require must pass through P0. This is equal to 3 minus 2, 1. It must pass through the point 3 minus 2, 1, and it must be parallel to this line. X is equal to 1 plus 2t, y is equal to 2 minus t, z is equal to 3t. So this implies, you know the parametric equation, x is equal to x naught plus v1t x of t. This is actually equal to x of t, and y of t, this is equal to y naught plus v2t, and z of t, this is equal to z naught plus some v3t. So this is the parametric equation. So you have from this and from this, this will be v1 and this will be minus 1 will be v2 and 3 will be v3. So you have v1, v vector v is v1i, v1 is v is, so v1 is, so you have this, take one, v1 equal to 2, get v1 equal to 2, v2 equal to some it is minus 1, and v3 equal to 3. So this is the vector, the required vector, which is actually parallel to the line that we are going to construct. So what will be the parametric equation? Parametric equation of the required line. So required line is x of t, this is equal to x naught plus, x naught means the initial vector, initial point. So this passes through 3 minus 2, 1, means this 3 plus 2t, 3 plus 2t, y of t is minus 2 plus, sorry, minus 2 minus t, minus 2 minus t, minus 2 minus t, and z of t is what is the set naught? Set naught is 1, so 1 plus 3t, 1 plus 3t. So this is, so t belongs to minus infinity, infinity. So what we have done is From the given line, you find the required vector parallel to the line passing through 3 minus 2, 1. So this is the parametric equation of the line. Our problem is to find the parametric equation of the line. So question is like this: find the parametric equation of so now you can plot this line in our GeoGebra. See what happens. So you have already done something like this. So you have the given line and the given vector. Given vector, and you have found a point. You have to find the line passing through A and parallel to the given line. So for which our newly found P0 P0 is this one, A. A is our new P0. So you may take that as you already taken M and N, you take R and S. R equal to our new initial position 3 minus 2, 1. 3 comma minus 2 comma 1. So you have, now you can see that you have the our point and you have the vector at that point, position vector of the point A. Now you write the vector. So that vector is this one itself. S is this vector itself, this one. So you can have S, either you can have S is equal to N, or you can directly substitute 2 minus 1, 3. S is equal to 2 minus 1, 3. 2 comma minus 1 comma 3. Enter. So you can have S C we plot y is equal to r plus t star s. Y equal to r plus t star so how this is the required line. We color it as some blue. So this so our original line was the red line, and the new line is the derived line. So what we have solved is the blue line, this one. So our question was to find a line parallel to this one and passing through A. So this is the solution. And its equation is 3 minus 2, 1 plus lambda times, or t times 2 minus 1, 3. So x naught is 3 plus 2t. You already have 3 plus 2t. And y is minus 2 plus minus t, and z is 1 plus 3t. So that you have. So this is the way we have to check how is our solution is correct, and you have some idea regarding lines in space from this. So we may stop here for the day. Okay.